How to identify whether the problem is of discrete or continuous? If you are able to write it in the form of a table or the tabular form is given, then it is under discrete, otherwise it is a continuous random variable problem. Okay, so you will be asked to find out the k value, mean value, variance value there, okay, in discrete and continuous cases, and CDF problems, cumulative distribution function problems will be there. Okay, so write one problem fast. I'll give you small problems only, I'll try to give, okay, so that I can cover all the topics. A sample of 4 items is selected at random from a box containing 12 items, of which 5 are defective. Full stop. Find the expected number E of the defective items. I did not give you the tabular form because I said that when you are able to write it in the form of table or tabular form is given, then it is discrete. Now look at that and try to write the tabular form. Okay, here we are talking about defective items, right? So how many are good, how many are not good, we have to separate them and we have to find out their respective probabilities. Okay, so how many are good given? 12 items are there, right? 12 items. In that how many are good? 7 are good and 5 are not good, so 5 are bad or 5 are defective items. Okay, so I'll write here 5 are defective. Then we have to get the tabular form. Let X represent the defective items. Then you have to get the tabular form. X is equal to X, P of X is equal to X. So 0, 1, 2, 3, 4. How many they are selecting? Maximum is 4 or any? 4. So 0, 1, 2, 3, 4. Then 0 defective items. 0 defective means you have to select all from the good items. Good items. You are selecting 4 out of 12. You are selecting 4 out of 7. So that can be written as 7C4 by 12C4. 7C4 by 12C4. Then 1 defective should be there. 1 defective and the remaining 3 should be non-defective. Is it talking about defective only? Yes. So 1 defective. 1 defective means 5C1 into 7C3 by 12C4. Then 5C2 into 7C2 by 12C4. 5C3 into 7C1 by 12C4. 5C4 by 12C4. Wantedly I did not take the tabular forms because I want to tell whether if you are able to write it in the tabular form, we can use. Okay. Then we are getting some values. What are they? 7C4 by 12C4. What is 12C4? Find out fast and tell me these values. Tell me these values. One of you do this one, do this one. And then what is 7C4 by 12C4? 0.06. 07. Next. 0.35. Next. 0.42. What is 5C4 by 12C4? 01. Last one 0.01. 0.14. Then if X represents defective items, then E of X represents expected number of defective items, which is given by summation X into F of X or summation X into P of X equal to X. This into this, this into this, this into this and so on. Okay. So that becomes 0 into 0.07, 1 into 0.35 plus 2 into 0.42 plus 3 into 0.14 plus 4 into 0.01. That will become expectation 1.6. That will become the expected value of defective items. If suppose you are asked to find out k value, you have the properties, okay, that is f of x should be greater than or equal to 0 and summation f of x is equal to 1. If you are asked to find out the value of k, then sum all the individual probabilities and equate it to 1, then that will give you the constant. Okay, then write this one. If the probability density function if the PDF of random variable is given by f of x is equal to k into 1 minus x square for 0 less than x less than 1 and 0 otherwise, k into 1 minus x square for 0 less than x less than 1, 0 otherwise, find the value of k, and probabilities that a random variable having this PDF will take on a value between 0.1 and 0.2. PDF is talking about PDF, right? Continuous random variable, right there. Since x is a continuous random variable and f of x is PDF, then f of x should be greater than or equal to 0 and integral value f of x dx is equal to 1. PDF, we wrote that it satisfies the two properties. F of x should be greater than or equal to 0 and integration value will become 1. So, k into 1 minus x square should be greater than or equal to 0. It means k should be greater than or equal to 0. K into something should be greater than or equal to 0, then k should be greater than or equal to 0. First condition. And integral minus infinity to infinity f of x dx is equal to 1. But see that you are given 0 to 1 we have f of x something and otherwise we have answer as 0. So, we will split this. So, minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx equal to 1. Then here we have answer as 0, here we have k into 1 minus x square and here we have 0 equal to 1. So, k into integration of this x minus x cube by 3 and the limits are 0 to 1 equal to 1. So, if we apply here 1 minus 1 by 3 equal to 1. So, 2 by 3. So, k is equal to 3 by 2. So, like that we have to find out k. Then mean and variance also you can find out. Okay, better I will write mean and variance also for this. Okay, we will write in the question write there mean and variance also, because one problem I will tell you mean or at least write mean. Okay, mean is equal to integration minus infinity to infinity x into f of x dx. So, which is equal to here and here we have the answers as zeros. So, only we will take the interval in which f of x is specified as non-zero. So, 0 to 1 k into 1 minus x square into f of x dx. Okay, x into f of x dx. This is your f of x. F of x is k into 1 minus x square. X is as it is. So, x into k into 1 minus x square into dx. K is 3 by 2. So, 3 by 2 will take it out. 0 to 1 x into 1 minus x square. So, x minus x cube dx. So, which becomes 3 by 2 x square by 2 minus x power 4 by 4 0 to 1. So, 3 by 2 1 by 2 minus 1 by 4 1 by 4. So, 3 by 8 is the mean. Similarly, you can continue and you can write variance also. And you are given there to find out P of x lying between 0.1 and 0.2. Okay, 0.1 and 0.2. P of 0.1 less than x less than 0.2, which is nothing but 0.1 to 0.2 f of x dx. F of x we got that as 3 by 2 into 1 minus x square. So, that becomes 0.1 to 0.2 3 by 2 into 1 minus x square into dx. So, that becomes 3 by 2 x minus x cube by 3 0.1 to 0.2. So, that becomes 3 by 2 0.2 minus 0.008 by 3 minus 0.1 minus 0.001 by 3. You will get some answer. So, likewise you have to calculate mean, variance and the probabilities for discrete and the continuous random variables. So just you need to concentrate on the procedures, how to calculate them, that's all. Then we'll take binomial. Let's write one question on binomial. Write this: the probability of a defective bolt is 1 by 8. Find mean, second bit, variance for the distribution, mean, variance for the distribution of defective bolts of 640. Mean and variance. How we wrote mean and variance of binomial distribution? What is mean of binomial distribution? NP. What is variance of binomial distribution? NPQ. You have n, 640 is your n. What is P given? P is 1 by 8. Q is 7 by 8. So substitute and get the mean and variance, that's all. Fast. Mean is equal to NP, variance is equal to NPQ. The next 80, 70. Next. Determine binomial distribution for which mean is 4, variance is 3. Determine binomial distribution for which mean is 4, variance is 3. Mean is 4, variance is 3. Mean is, how you are writing mean? NP. So NP is 4, NPQ is 3. So solve them. NP by NPQ or NPQ by NP. Take that and solve. Then you will get n value, P value, Q value. Put the distribution. What is n value you are getting? N is 16. P value 1 by 4. Q value 3 by 4. So distribution will become P plus Q whole power n. P plus Q whole power n. How we are writing it? NCX, P power x, Q power n minus x. Right? So P plus Q whole power n. So that becomes 1 by 4, 3 by 4 whole power 16. The next, in 8 throws of a die, okay, after this we'll go to Poisson. Okay, in 8 throws of a die, 5 or 6 is considered as success. In 8 throws of a die, 5 or 6 is considered as a success. Is considered as a success. Find the mean number of successes. Find the mean number of successes and standard deviation. Find the mean number of successes and standard deviation. What is n? N is 8. Then what is P? See that what he has given here, getting 5 or 6 is considered as success. Getting 5, chance is 1 by 6. Getting 6, chance is 1 by 6. So together will become 2 by 6, that is 1 by 3. So P is 1 by 3, Q is 2 by 3. So NP, NPQ. Mean and standard deviation. Standard deviation, root of NPQ. Yes. Okay, next. Out of 800 families with 5 children each, how many would you expect to have 3 boys? Out of 800 families with 5 children each, how many would you expect to have 3 boys? How many would you expect to have 3 boys? Assume equal probabilities for boys and girls. Assume equal probabilities for boys and girls. Then what will be P? P equal to 1 by 2. Q is 1 by 2. And what is N? Small n. Okay, whenever a big number is given, it is capital N, not small n. Okay, 5 children each. So that 5 is N5. That number is small n. Small n is equal to 5, capital N is equal to 800. Write that. Whenever you are given a bigger number, it is capital N. Whenever the bigger number is given, you will be asked the question as how many. Okay, not the chance. How many will be asked. Okay, small n is 5, capital N is equal to 800. Capital N is equal to 800. So, what you have to do is, for a single family, you have to calculate the chance of having 3 boys, then you have to multiply it with the capital N, then you are going to get how many families have 3 boys. Okay? So, what you have to do is, so n is given as 5, P is half, Q is half, capital N is 800. Okay, for a single family, what is the chance to have 3 boys? We have to calculate. Then we have to multiply it with all the families. Then we have to take out how many families will have 3 boys. Okay, so P of x is equal to 3. If we denote x as boys, so 3 boys will become P of x is equal to 3, which is nothing but NCX, P power x, Q power n minus x. Okay, n is 5, so 5C3, half power 3, half power 2. This will give the chance for a single family. You have to multiply it with the 800 families, you will get the number. What is the answer? 5 by 16. Okay, so then number of families having 3 children, 3 boys is equal to n into P of x is equal to 3, which is 800 into 5 by 16. So how much you are getting? 250. So 250 family has 3 boys out of 800. Then in Poisson, we wrote that P of x is equal to x is e power minus lambda, lambda power x by x factorial, and mean and variance are denoted with lambda, right? So when we use Poisson, I said yesterday that when n is tending towards infinity, means n values are very large and p is coming closer to 0, then we are going to replace binomial with Poisson. Okay? Otherwise, we have to give preference to binomial only. Average number of accidents on any day on a national highway is 1.8. Determine the probability that the number of accidents are at least 1. That the number of accidents are at least 1. At least 1 means what do you have to calculate? At least 1. Yesterday I told you that at least 1 is 1 minus probability of none. Okay? So P of x greater than or equal to 1 we have to calculate, which is nothing but 1 minus P of x is equal to 0. At least 1 minus probability of none. And see that you are given average number of accidents, directly given average, that is lambda value is given. Given lambda is equal to 1.8. So 1 minus e power minus lambda, lambda power 0 by 0 factorial. Or sometimes n and p will be given, you have to club them and you have to get lambda. Okay? Then we'll do only one more problem in this, then we'll move on to normal. Next, if capital X is a Poisson variate, such that 3 into P of x is equal to 4 is equal to half P of x equal to 2 plus P of x is equal to 0. Find mean of x. Find mean of x. Find mean of x. So this becomes 3 into e power minus lambda, lambda power 4 by 4 factorial, half e power minus lambda, lambda square by 2 factorial, e power minus lambda, lambda power 0 by 0 factorial. So from all we can cancel e power minus lambdas, then we'll get that as 3 by 24 lambda power 4 is equal to 1 by 4 lambda square plus 1. Then we'll get the value of lambda, which is nothing but mean. Lambda is 2 or minus 2. Root 2 will also? Root 2. But can we get minus 2? Is there any possibility to get minus 2? Because lambda is defined as NP. P is not negative, N is not negative. So minus 2 you won't get. So this is false. Right? So lambda can be 2 or root 2. Root 2 you are getting? Then take those values. Okay, whatever the value you are getting, take that. Okay, then next. Normal. So normal I did not start yesterday. This is PDF of normal, where minus infinity less than x less than infinity, and mu value also lies between this, but sigma is greater than 0. When we convert it to standard normal form, z is equal to x minus mu by sigma. Standard normal form. Standard normal form. In all the problems we need to use the standard normal form, and you have to see the distribution tables which you got in your group I have sent. So whenever the problem is given like binomial and Poisson, they were discrete, we were able to calculate it easily, but here in normal it will take time, and most of the problem will get solved by using normal distribution. It is very important throughout the statistical theory. It is very important distribution. Z is equal to x minus mu by sigma. Okay, so here mu and sigma are parameters of normal distribution. This is also called as Gaussian distribution. Don't get confused. Sometimes it is also given as Gaussian distribution. Normal distribution or Gaussian distribution. Okay. In the normal distribution case, mean equal to median equal to mode. All the three will coincide. They will be at the same point. Mean is here. Median, it's the line which divides the region into two equal parts. So this is 0.5, this is 0.5. The area under this curve is 1. Okay. According to mode, the curve where it has peak or maximum is at this point only. So therefore we can say that mean, median, mode, all the three coincides at the same point. Mode is the value of x for which f of x is maximum, or which repeats more number of times. From the curve you can see that it is maximum at the line x equal to mu only. So therefore we can say that mean, median, mode coincides in the normal distribution. The next, mean deviation about mean. Mean deviation about mean is equal to 4 by 5 times of standard deviation approximately. Mean deviation about mean is approximately 4 by 5 times of standard deviation. 4 by 5 times of standard deviation. So whenever the problem is given in terms of x, you have to change it to z first by using the standard normal form. Then we have to see the standard normal distribution tables to get the answer. Yes, write the question. If capital X is a normal variate, in this we have two varieties. I'll tell you two varieties. If capital X is a normal variate with mean 30 and standard deviation 5, with mean 30, if capital X is a normal variate with mean 30 and standard deviation 5, find the probability that 26 less than or equal to x less than or equal to 40. Okay, that is we have to find out P of 26 less than or equal to x less than or equal to 40. I said that x is a normal variable. To use the standard normal distribution tables, we need to convert it to z. Z is equal to x minus mu by sigma. Given mean mu is How much he has given mean? Mean 30. And standard deviation, sigma is equal to deviation is 5. Then we have to convert this to z first. Convert this to z. Okay. So this will become P of 26 minus mu by sigma less than or equal to z less than or equal to 40 minus mu by sigma. Z is equal to x minus mu by sigma. This is your x value. Minus mu by sigma. This is your x value. 40 minus mu by sigma. So this gives P of 26 minus mu 30 by 5 less than or equal to z less than or equal to 40 minus 30 by sigma, that is 5. So P of minus 4 by 5, so minus 0.8 less than or equal to z less than or equal to 10 by 5, that is 0.2. Sorry, 10 by 5. Right. Then you have to draw the figure. So this becomes minus 0.8 to 2. Okay, normal distribution curve when converted to standard normal form, this takes the shape of z is equal to 0, minus infinity, plus infinity. X equal to mu will get replaced with z is equal to 0 because at x equal to mu z becomes 0. Z is equal to x minus mu by sigma. When x is mu, z is equal to mu minus mu, so 0. So at this point z becomes 0. So this becomes z is equal to 0. So I have z lying between minus 0.8 to plus 2. So it will start at somewhere here minus 0.8 and here 2. This is the region he is asking. Right. So we have to split that in two parts. Always it should have with 0. Always it should have with 0 as the lower limit. Okay. Then we can write it as minus 0.8 to 0 f of z dz plus 0 to 2 f of z dz. Right up to that I forgot to tell you the properties. I will tell you properties, then we will continue this. So besides that, write the properties also. I will write here. Okay, after this write their properties. Minus infinity to infinity f of z dz is equal to 1. Minus infinity to 0 f of z dz is equal to 0 to infinity f of z dz is equal to 0.5. Minus a to 0 f of z dz is equal to 0 to a f of z dz. Minus a to a f of z dz is same as 2 times of 0 to a f of z dz. These are the properties. This side whatever the area you have, this side also you will have the same area. So minus a to a is same as 2 times of 0 to a. So now from this you can see minus a to 0 is same as 0 to a. So whenever you get limits in terms of negative, you have to convert it to positive because we cannot see that in the table, right? So this is of the form minus a to 0. So you have to convert it as 0 to a. Always we should see that the lower limit is 0. The lower limit should be 0 and the value of 0 in the table will be always 0. So we need to see only upper limits. So we can write this as 0 to 0.8 f of z dz plus 0 to 2 f of z dz. So just we need to see what is 0.8 under 0, what is 2 under 0. Look at the tables. In normal distribution table or z distribution table, what is 0.8 under 0? If nothing is given, you have to see under 0. 0.8 under 0 is 0.2881. Then what is 2? 2 value, 2 under 0, 2.0 under 0, 0.4772. Yes, like that you have to see. No, whatever it is, you write. Okay, so 2 means 2.0 under 0, 0.8 means 0.8 under 0. If suppose you want 2.1, so see that 2 under 1, like that you have to see that. Then this was first variety of in normal distribution. Take the second one. In normal distribution, 7% of the items are under 35, but mostly you will get this type of problem only. Mostly. This second variety what I am giving now, because it becomes lengthy, I don't think that they will give. Mostly because I saw in papers also, they are asking this type of question. Okay, he is asking the chance. Okay. In a normal distribution, 7% of the items are under 35 and 89% are under 63. Determine mean and variance. Determine mean and variance. Okay, this will be little bit lengthy. So that's the reason I am saying that they may not ask. Okay, see that what he has given. 7% of the items are under 35. 7% are under 35. Under. If we see under, then that will be this side. This side, right? If I say over, then that will be other side, right? 7% under 35. So this is x equal to 35. This is 7%. Then what is the next one we have? 89% are under. Okay, 89% will be up to here. 63. So now look at this. 89% under 63. Under means again completely I have to shade this one. But see that there is an overlapping. Overlapping will not give you a correct answer. So what you have to do is you have to take over. Whenever two unders are given or two overs are given, you have to convert one in terms of the other one. Okay? Under should become over or over should become under. Both should not be of same category. Otherwise you will get overlapping. Okay? So 89% are under 63. So I can write that 11% are over 11% are over 63. So I can shade this region instead of shading this. So this is 11%. Right there. 89% under 63 is same as 11% over 63. Okay. Now what you have to do is, this is your 50% region. So here already 11% is occupied. So this becomes 39%. 0.39. And here already 7% is occupied. So this becomes 43%. Means 43.43. Then according to this, I should name it as z is equal to minus z1 because this z is equal to 0. Whatever I will get on the left side, that becomes minus. Whatever is on the right side, that will become plus. So z is equal to z2. Okay. Then z is equal to minus z1. I can write it as x1 minus mu by sigma. This is x1, this is x2. And here this is equal to x2 minus mu by sigma. x1 minus mu by sigma is minus z1 and x2 minus mu by sigma is plus z2. Okay. Now if I have two values, then I can calculate the other two values by solving the equations. So what are the two? I have x value here, yes, I can put x value, but the other value should also be there so that I can calculate mu and sigma, right? Means z value should also be there. Okay. So z1 minus z1 is equal to 35 minus mu by sigma. This I have. And here z2 is equal to 63 minus mu by sigma. So I need z values. So I will calculate from the figure. Okay. From figure what I have to do is, from here to here, I have 0.39 as the area. So 0 to z2, f of z dz is 0.39 and minus z1 to 0, f of z dz is 0.43. Minus to 0 is same as 0 to plus. I said just now, minus a to 0 is same as 0 to a. So this I can write it as 0 to z1, f of z dz is equal to 0.43. Now what you have to do is, see that this is the reverse case. Till now you were given z values, you were calculating probability or area, but here you are given the area, you have to locate the value of z. Okay, you have to see in the table where you have areas completely. Now look at that in the areas where you get the answer as 0.39 approximately 1.48. So I can write 0 to 1.48 f of z dz. Since 1.4 under 8 is 0.39. 0.39 where you have in the table, not z values, you have to find out z value. 1.23. So this is wrong then, 1.23. 1.2 under 3. So therefore, If I compare this and this is same, so therefore this and this should be same. It implies Z2 is equal to 1.23. Z2 is equal to 1.23. Similarly, you have to calculate this one. See, in the areas where you have 0.43, 1.48. So here this is same as 0 to 1.48 f of z dz. So it implies z1 is 1.48. Put this value here and here, okay, and solve it. You are going to get the values of mu and sigma. But I don't think that they are going to give this much lengthy, because I have seen the first variety of problem in some of the papers. I don't think that they will ask this much lengthy. Put those values of z there and get the value of mu and sigma by solving the two equations in mu and sigma. How much? What are mu and sigma? This was regarding normal distribution, sampling distribution. Okay, in sampling distributions we have sampling distribution of means when sigma is known, when sigma is unknown. Sampling distribution of means when sigma is known. Sigma is known. Okay, in this I think we can expect central limit theorem problems mostly. Central limit theorem, which is similar to a normal distribution problems. Okay. So better first write all the formulas which you can get in that. X bar is sample mean, S square is sample standard deviation, sample variance, xi minus x bar whole square by n. Then standard deviation is just the square root. Then population mean is summation xi by n, where this n is sample size and this n is population size. Then this is denoted with mu. Then population standard deviation is denoted with sigma, which is equal to sigma xi minus mu whole square by n under root. Population standard deviation. Sample mean denoted with x bar, sample proportion denoted with p bar, like that you will have. Okay. Sample mean x bar, sample variance s square, sample standard deviation s, population mean mu, population standard deviation sigma, population variance sigma square. Variance is sum of the squares of the deviations about the mean. Sum of the squares of the deviations about its mean. Its mean, we are talking about sample, then its mean is sample mean. When we are talking about population, its mean is nothing but population mean. So that's the reason I wrote two different things over there, xi minus x bar, xi minus mu. Number of samples that can be formed, of size small n, from a population of size capital N, from the size of the population capital N is NCN n power n. This is the case without replacement and this is the case with replacement. When you have without replacement, those many number of samples you can form. 5C2, suppose you have 5 elements in the population and you want to form samples of size 2, then 5C2, 10 samples you can form. When it is a case with replacement, then 5 power 2, 25 samples you can form. Okay. Then next, mean of sampling distribution of means. Mean of sampling distribution of means, which is denoted with mu x bar. How we calculate it? We have to get all the samples then we have to collect their means, then that will become sampling distribution of a means, then again you have to calculate its mean, then that is going to become mean of the sampling distribution of a means. Similarly, standard deviation, you have to collect all the samples, then their means, then you have to calculate standard deviation to that, then that is going to give standard deviation of sampling distribution of means. Okay? The sampling distribution of a means will be equal to population mean, as always. Mean of the sampling distribution of a means is always equal to population mean. But standard deviation of sampling distribution of a means, sigma x bar, okay, sigma x bar will not be equal to sigma. Mean of the sampling distribution of a means will be equal to population mean, but standard deviation of sampling distribution of means will not be equal to standard deviation of population, but it should be equal to something. So sigma x bar is equal to sigma by root n, sigma by root n into under root of n minus n by n minus 1. Okay, if this is the case with replacement finite or infinite population. Sampling is with replacement, population may be finite or infinite. Population may be finite or infinite. And in this case, finite population without replacement. Finite population without replacement. If you have a small population and the sampling is being done without replacement case, then you need to add finite population correction factor. This term is called n minus n by n minus 1 is called finite population correction factor. Finite population correction factor. These are all the small problems we can expect. They may ask standard error, finite population correction factors, central limit theorem problems. Okay, tell me, standard error is sigma x bar is equal to sigma by root n. Write that fast. Standard error of means is given by sigma x bar is equal to sigma by root n. When the sigma by root n, now look at that. As n is increasing, standard error will decrease or increase? As n is increasing, standard error will increase or decrease according to the formula. Sigma x bar is equal to sigma by root n. If the sample size n is increasing, what happens to the standard error? What happens? Decrease. If the sample size decreases, what happens to the standard error? Increases. Okay? Such question can also be asked. Sample size, they will give you two different sample sizes, then they can ask you what happens to the standard error, whether it is increases or decreases. If increases, by what amount it increases? If decreases, by what amount it decreases? Then write a note. If n is large, capital N. If capital N is large, then omit finite population correction factor. Then omit finite population correction factor because it approaches 1. It approaches 1. So no need of writing finite population correction factor when n is tending towards infinity. Okay. Then central limit theorem. Central limit theorem. We won't write theorem, no need to worry. Z is equal to x bar minus mu by sigma by root n. Z is equal to x bar minus mu by sigma by root n. In which case we have to write that. If x bar is the mean of random sample of size small n, taken from population with mean mu and variance sigma square, then z is equal to x bar minus mu by sigma by root n. When we have to follow this? When we are talking about means, when we are not talking about random variables. Okay, if x bar is the mean of random sample of size small n taken from the population with mean mu and variance sigma square, then z is equal to x bar minus mu by sigma by root n is also a random variable which follows approximately normal distribution. Approximately normal distribution. Let's write down the question. The variance of the population is 2, size of the sample collected from the population is 169, size of the sample collected from the population is 169. What is the standard error of mean? What are the values given? Is that sigma value given or sigma square value given? Sigma square. Sigma square is 2, so sigma is root 2. And what else is given? Sample size. So small n is equal to 169. So standard error sigma x bar is equal to sigma by root n. So root 2 by 13. So that becomes the standard error. The next, when a sample is taken from an infinite population, what happens to the standard error of the mean? What happens to the standard error of the mean? If the sample size is decreased from 800 to 200, what happens to the standard error? Standard error 1, 800, 200. So when 800, we have sigma by root 800. Standard error 1 is equal to sigma by root 800 and standard error 2 is equal to sigma by root 200. Then this 800, we can write it as standard error 1 is equal to sigma by 2 into root 200. 2 into root 200, which is same as half times of standard error 2. Half times of standard error 2. We can write it as standard error 2 is twice the standard error of 1. It means that when the sample size is decreasing from 800 to 200, the standard error is doubling. It's getting doubled. It's getting doubled. Write this. A random sample of size 100 is taken. A random sample of size 100 is taken from an infinite population having mean mu equal to 76, variance sigma square equal to 256, sigma square equal to 256. Then what is the probability that x bar will be between 75 and 78? X bar will be between 75 and 78. See that this is similar to the normal distribution problem what we have written. There we had x and here we have x bar. Whenever we are talking about sample means, we have to use central limit theorem. Whenever we are talking about the random variable x, we have to use standard normal form. Z is equal to x minus mu by sigma. When we are talking about x bars, x bar minus mu by sigma by root n. Okay, that change will there. So he is asking us to find out P of x bar lying between 75 and 78. Right? For this we have to use central limit theorem, that is z is equal to x bar minus mu by sigma by root n. So it means that we need the values of mu and we need the value of sigma here and we need the value of n also here. What is mu given? 76. Sigma Is that 16? Sigma square is, acha, okay, sigma square is 256, so sigma equal to 16. What about n? N is 100. Sample size n is equal to 100. Then this becomes P of 75 minus mu by sigma by root n less than z less than 78 minus mu by sigma by root n. Mu value is there, sigma value and root n, substituting that, okay. So this is equal to P of 75 minus 76 by sigma 16 by 10 less than z less than 78 minus 76 by 16 by 10. This becomes similar to the problem of normal distribution. How much? 0.62 less than z less than, final answer. What about this answer? 0.26, no, minus 0. Minus 0.625, 1.23. So this we can write it as minus 0.625 to 1.23 f of z dz, which is same as minus 0.625 f of, yes, we have to split this, minus 0.625 to 0, 0 to 1.23. So 0 f of z dz plus 0 to 1.23 f of z dz. But in distribution tables we can see only 2 decimal places. So 0.63 only we have to take. We should not take 625. And minus a to 0 is same as 0 to a. So we can write it as 0 to 0.63 f of z dz plus 0 to 1.23 f of z dz. So 0.6 under 3, 1.2 under 3, you have to see the values. 0.6 under 3, 1.2 under 3. What is 0.6 under 3? 0.2357. What is 1.2 under 3? 0.3907. So this variety you may get in your exam by using central limit theorem. So you have to keep in mind that when we are talking about only x, random variable x, we have to use z is equal to x minus mu by sigma. When we are dealing with means, sample means, then we have to use central limit theorem, z is equal to x bar minus mu by sigma by root n. If he is asking only about the random variables, then x minus mu by sigma. Then we will move on to estimations. So in these estimations, we have 3 types of estimations: point estimation, interval estimation and Bayesian estimation. Bayesian estimation, okay. Point estimation is, we don't have any question based on that, okay. It is just a single value by which we are able to estimate the value of the population, okay. That is called as point estimate. We will have the questions on interval estimation, we will have the questions on maximum error, we will have the questions on sample size, and we will also have the questions on Bayesian estimation. I was telling about interval estimations, right? Interval estimation, point estimation and Bayesian estimations, okay. So the questions we may get from this is how to calculate the maximum error, sample size and confidence intervals, okay. Yes, these are all the formulas for standard error. First one is for large sample, single mean. The second one is for proportions, single proportion. Third one is for small sample, single mean. Similarly, you can write for whenever you have small sample, when sigma is unknown, you have to use t distribution. Till now we were using z distribution. Whenever the sample is small, you have to use t distribution. I will tell you some problems on t also. T alpha by 2 at nu nu is degree of freedom, T alpha by 2 comma nu, or here at nu degree of freedom, T alpha by 2 at nu degree of freedom. Nu is nothing but n minus 1, nu is equal to n minus 1 degree of freedom. Maximum error. Then from this only we can calculate the sample sizes. Yes, just you have to reverse it. When all the other items are given, you can calculate sample size also from this. Okay? Sample size can be calculated from above formulae. Do we use this formula to calculate sample size? T alpha by 2? Do we have to use? If it is a small sample, we can count. We never use T alpha by 2 for calculating the sample size, because T alpha by 2 we use whenever we have a small sample. Small sample is nothing but n is less than 30. N less than 30, we get a small sample. N greater than or equal to 30, we get a large sample. N less than 30, why we use the formula? We'll count it. We'll count the elements. Why we need this? Right? So, remember that we never use T alpha by 2 for finding the sample size. We use Z alpha by 2 every time. Okay? Because nu is equal to n minus 1 degree of freedom. From where you will get n minus 1? You don't have n. So you should not use this formula whenever the sample size is small. Always you should use this one only. You should not use T alpha by 2 anywhere. Okay, for sample size. Then confidence interval. Okay. X bar minus E less than mu less than X bar plus E. This is for confidence interval for mean, single mean. P bar minus E less than P bar plus E for single proportion. If you calculate E, just subtract with that X bars and P bars, you are going to get some interval, that is nothing but the confidence interval. For 95% confidence, Z alpha by 2 is 1.96. You remember this. For 99% confidence, Z alpha by 2 is 2.576. For 90% confidence, Z alpha by 2 is 1.645. Directly you can use them. You can also check from T distribution. Even though it is written as Z, you have to see in T. I'll show you that. You should not see in Z. You won't find alpha there. Z alpha by 2 values you should see under T distribution at last row. I'll give the clarity how we are writing this, or how to check from the table also. Yes, look at this. 95% confidence, 5%. Alpha is 5%. Alpha by 2 is 2.5%. 0.025. Now go to T. See under alpha equal to 0.025 last row. 0.025 last row, you will have 1.96. Okay? You can see in that way also. Now, write a note there. In proportions, if p value is not given, sometimes p value will not be given, only find out confidence interval, that's all. P value is not given, then take p equal to q equal to half. Whenever not given, you have to take them as equal preference. P equal to q equal to half, or equally likely. In proportions, If Z alpha by 2 is not given, then replace it with 3, number 3. Z alpha by 2 you can replace with 3. That's the standard notion we have. And for all the remaining cases, if no confidence is given, then you can use either 95% or 99%. It's up to you. Most of the cases will be using 95% and 99%. Okay? In proportions, it is a notion that whenever Z alpha by 2 is not there, you can just replace it with 3. Whenever P and Q are not there, then you can replace it with half. Okay? In textbooks we have some mistakes, so to avoid that, I will be using generally, instead of small p, small q, capital P, capital Q, I will use it as P bar, Q bar for samples. I wrote that as sample mean. Similarly, P bar as sample proportion. X bar sample mean. Mu population mean. Similarly here, P bar sample proportion. P population proportion. To avoid mistakes, because I saw many cases where there are printing mistakes. So to avoid that, I will be using these as the notions. P bar for sample proportion, P as population proportion. Okay? So we will do some problems on that. Write this one. A random sample of size 100 has standard deviation 5. What can you say about maximum error? What can you say about maximum error with 95% confidence? With 95% confidence. Then write the next one there. I will give 3 different questions which can cover all the 3. A sample of 400 items is found to have, take this one, it is desired to estimate the mean number of hours of continuous use until certain computer will first require repairs. Until certain computer first require repairs. If it can be assumed that sigma equal to 48, how large a sample be needed so that one will be able to assert means saying with confidence. Assert means saying with confidence. One will be able to assert with 90% confidence that the sample mean is off, OFF. Sample mean is off by at most 10 hours. By at most 10 hours. At most 10 hours. So look at that first question. You have to calculate both the things, that is maximum error and sample size, confidence interval. But I told you that for confidence interval, we will however find maximum error, because I made you write in that way. I did not make you write x bar minus z alpha by 2 into sigma by root n, because for remembering it is difficult. So that's the reason, in simple way, x bar minus e, x bar plus e, that's all. What is e? E is z alpha by 2 into sigma by root n. Okay? So maximum error is E is equal to z alpha by 2 into sigma by root n. What is the data given in the first one? Second one. I said first one will leave. N is equal to 400. Sigma is given 18. Is any other data given? Mu is given. Mu not required. 95% confidence. 95% confidence that z alpha by 2 is, I told you that. When 95% confidence is given, then z alpha by 2 you can write directly 1.96. Okay. So this will become 1.96 into sigma is 18 by root 400. So 1.96 into 18 by 20. that becomes E. 18 by 20, roughly 1. So it will be around 2, I think. 2 or 1.7 something, yes, less than that. 1.76. E is equal to 1.76. Then 95% confidence interval is x bar minus E less than mu less than x bar plus E. X bar, achha, x bar is given, not mu. You are saying mu. How to identify? Listen, in the sentence, if he is talking about sample, then it is nothing but sample values are given there. If in the other sentence he is saying something, then it may be population values. See that he started with sampling, right? He said sample size, then it should be the sample mean only, not population mean. Because we are finding for population mean only. The confidence interval is for population mean. So he won't give population mean value there. Okay. And even this is wrong. This is S. This is wrong. Sample standard deviation is given. Okay. Then x bar is given as x bar. How much? 82. Now S is given, okay, but see that when the population, when the sample is large, whenever sigma is not there, you can replace sigma with S. Write down that. When the sample is large and sigma is not there, then you can replace sigma with S. You can replace sigma with S. Because the sample is large enough, you can take its value as the population value there. So I can write here sigma by root n, okay, as S by root n. Since sigma is not given, I can replace it with sigma S. Okay, replace sigma with S value. So I'll get this x bar minus E. So 82 minus 1.76 less than mu less than 82 plus 1.76. So that will give you confidence interval. Then next one, if you see, I gave the problem on sample size. Sample size. Okay. So sample size we can calculate from E only. E is equal to Z alpha by 2 into sigma by root n. Just reverse it. So Z alpha by 2 into sigma by E whole square is nothing but n. Shuffle the terms. Now, if you see your data, you should have sigma value, you should have E value, you should have Z alpha by 2 value, then only you can calculate N value. Are all data there in that? Yes? Is sigma given? What is sigma? What is Z alpha by 2 he has given? How much confidence he has given? 90? 99? 90%. 90% confidence. So Z alpha by 2 will become 1.645. We have written there. For 90%, 1.645. And go 10%. 10% divided into two parts. 5%, 5%. So you can see in the T alpha distribution table, you will get 1.645 in the last row. So 1.645. So 1.645, and what is sigma value given? Standard deviation. I told you already that when sigma is not given, you can replace it with S. Okay. So 48. Now E. Is E given? Is E given? So error. It's an error. Okay. Sample mean is off by at most 10 hours. So it is nothing but E. That is 10 whole square. So what is required and what is given, you have to check in the problem. If all the data is available, then you can calculate the required one. So it should have sigma, it should have Z alpha by 2, and it should have E value, then we can calculate the sample size. What is the sample size? 62. Squared it after squaring. Yes, write this question. In a random sample of 160 workers, exposed to certain amount of radiation, 24 experienced some ill effects. 24 experienced some ill effects. Full stop. Construct 99% confidence interval for the corresponding true percentage. Construct a 99% confidence interval for the corresponding true percentage. Now look at that. How to identify whether it is a problem of means or proportions? If it is a problem of means, then he will give you mean and standard deviation. Otherwise, it's a problem of proportion. Okay, if nothing of such type is given, then it is nothing but a problem of proportions. Okay, so P bar minus E less than P bar plus E. So we need first maximum error. Okay, maximum error E is equal to Z alpha by 2 into under root of P bar Q bar by N. P bar Q bar by N, sample values. Because one more thing you have to remember, that if population values are there, you should give preference to population values only, P Q by N. If suppose we don't have population values, then give preference to sample, because we are calculating for population only. So we are calculating the interval for population, so it doesn't have any population proportions. So you have to use only sample proportions here, P bar Q bar by N. Okay. So what is confidence interval given? Confidence given 99%. So 99% confidence. Then Z alpha by 2 is 2.576. 2.576. And what is P and what is Q given? Look at that. How many got or how many experienced ill effects? 24 out of 160. So we have to calculate the proportion. Okay. Sample proportion is P bar equal to X by N. So out how many experience? 24 out of 160. That is P bar. These many out of these many. Right. So that will give you the proportion. So 24 by 160. That will give you P bar. Then similarly you can calculate Q bar, which is nothing but 1 by N is P bar. P bar is 24 by 160, okay. Achha, okay. Will you calculate directly here by putting that? Okay, it's up to you. It's up to you. So Z alpha by 2 is 2.576 into under root of 24 by 160 into remaining part 136. 160 by root n. Root n means by n. N is how much? 160. So that will give you maximum error. Better you calculate 24 by 60, 160, because we need here also. We need here also. What is 24 by 160? We need that here. 0.15. So this will become 0.85. So here I need this. So 0.15 minus something is less than P less than 0.15 plus something. That will give you confidence interval for proportions. So we have done estimations for means, estimations for proportions. How much? Substitute there. Bayesian estimation. Bayesian. Nx bar sigma naught square plus mu naught sigma square by n sigma naught square plus sigma square. Sigma naught square by n sigma naught square plus sigma square. That is for, first of all, before going to that, I will tell you what is the Bayesian. N sigma naught square sigma square by n sigma naught square plus sigma square. Okay. So in Bayesian estimation, just I'll give a rough idea and I'll stop. Okay. So you can calculate that later. Okay. So what is there in estimation and this? What is the change? So actual estimation, what we will do is by seeing the sample value, we'll try to guess the population value. Like if I see a class of 100 and if I get the idea that 30 students passed, or suppose from 30 which I met 20 passed. So I'll generalize that for the class that okay, maybe 40 to 50 might have passed. I'll generalize it. That is called as estimation or point estimation. Okay, I'm taking a single value and I'm giving the single value as the answer. By taking the single input, if I'm trying to say that okay, maybe 40 to 50% might have passed, and a 40 to 50% confidence interval. Okay, but here in this Bayesian estimation, not only sample values, not only the sample values which matters, it is the person's assumptions also which matters. It is the person's assumptions also which matters. If he has sample mean, if he has sample variance, he is trying to calculate population mean, population variance in normal estimations. But here his assumptions are also taken. What are those assumptions? Sigma naught and mu naught. The person who is calculating, he is supposing that okay, maybe this much, maybe the mu may be this much, sigma may be this much. His assumptions. So by taking into his assumptions also into consideration, estimation is done. Not only sample values, his assumptions are also taken in consideration for estimating the values. Such estimation is called as Bayesian estimation, where the assumptions are also taken. Okay, so that type of estimation is Bayesian. Okay, so we'll stop.